the part two, storage spaces. Again, talked about in Windows 10, also used in Windows Server. Go figure, having the same kernel, having the same basic functionalities. They're going to be able to do the same thing. Your storage space uses the concept of just a bunch of disks. You can add these disks that are not part of any array together into storage space, creating a pool. That way it's all software monitored instead of relying on hardware. As you build that pool, Windows will see it all as one drive, one logical drive instead of the physical disks. You'll be able to do things like data deduplication. In case of accidental deletion or modification, you have copies. And you can either do the simple, the mirror, or parity. The simple space is the equivalent of a RAID 0. Just a stripe. We're using all the available data across, and we have no real backup to anything. The mirror space is similar to RAID 1. Whatever is on this side will be immediately copied to this side. And our parity is just like RAID 5. Taking a piece of each drive and having part of the parity. In case a drive goes down, we still have the data and are able to copy back when the new disk is in place. With storage spaces, we have the storage tiering, combining SSDs with HDDs together. So any of your most frequently accessed data will sit and live in the SSD. Everything else will be in the slower disk, similar to VMware's vSAN. Creating them is just the same in either edition of Windows, making the pools, making the disks, and the volumes. It looks a little different because everything is within Server Manager instead of Control Panel. But the basic steps are just the same. Here is our disks, our physical disks that we're going to turn into our pool. There is the virtual disk created from these. So our just a bunch of disks that are directly connected to the motherboard, either through hot swap, through the front, through inside. We create those into pools, and then those pools become available as the virtual disks to Windows. No surprise, you can do this all within PowerShell. Since it is software-based, we can always expand the pool, adding new disks. We can do it within the disk management. We can also use PowerShell to do the exact same thing. So just as in both, we can get the same information, do the same work. It really comes down to which way do you want to go? Do you want to type most of the time or click your way through? Since we're talking about physical, we know that our disks will fail. That is just part of life. So there are options and ways to bring up a new disk to take an old disk's place. and you can do it both within the GUI or through PowerShell. You can also have Windows have some extra drives on standby through hot spare, for example, or through automatic, where the in automatic storage space will choose which one is hot spare and which one isn't. Hot spare, you choose these disks will sit. So in this example, we have a few disks that are automatic. We have a few manual where the admin will decide to bring this disk online or not. These guys will sit as hot spare. So if anything happens to the first two, these two take their immediate place, giving you time to find another disk to replace while not affecting the performance and any downtime to your users. So again, you could do this, you can have this do it manually, or you do it yourself, or have Windows do it for you. In high usage scenarios, I would go with the automatic, just so that Windows can alert you and it already took action for you, so your users continue working as normal and you can fix it and nobody knows. Enclosure awareness is a nice feature. Oh, I see a question. Break down the difference between hot spare and automatic. So in automatic, storage space does the decision making for you. A hot spare, you have specifically chosen a disk to sit idle until it is needed. So where's that picture? So in this case, Windows will take these first two drives and decide whether to put them active or have them in standby. These last two are going to be in standby until any of the automatics go down and take that place. And these two in the middle, you, the administrator, have to say, okay, we're either going to go automatic or hot spare if and when these first two drives die. So yeah, enclosure awareness is a kind of parity for the disk, ensuring copies of data is on other drives in case a drive dies. Because like I said, we're talking about hardware, and hardware will fail. So this is a good feature to have enabled. That way there is no downtime for your users, and you can still fix the problem while everybody else is still working. Tiered storage, or the similar to vSAN, you have to have at least one SSD and one HDD as a pair. If for whatever reason Windows doesn't see that it's an SSD, you can physically set it as that, and then you'll create those tiers. Here is the GUI. Of course, you can do all this with PowerShell as well. And then you choose, okay, which is my faster tier? How much of the disk space do we want to use from the SSD? And how much do we want to use on the other disk, on the slower disk? Either specifying a size or using the complete space within it. Oops, I went backwards. Here's the PowerShell way to do it. So like in this final example, we have 40 gigabytes being eaten out of an SSD and then 200 out of a spinning disk. Changing gears again into iSCSI, another form of network storage, just like NAS, using the logical unit numbers or the LUNs. This is where we use fiber and any other high-speed connectivity through a SAN. Can work over an IP network. And really, and ideally, you want to have your iSCSI traffic on a different backbone than everything else, since we're talking about high-speed storage. For example, to run virtual machines or to run critical infrastructure, it's good. It's a good idea to have iSCSI running on a high-speed backbone. The two main components are the target and the initiator. The target is just another fancy way of saying a client, and the initiator is just another fancy way of saying the server. Actually, I have it backwards. The target is the server, the initiator is the client. So many terms. So many terms. Every tech has its own little set of terminology. So here we go. We have our clients that are connected to our server over here, who is the one who has the shared storage. So if that confused you, don't worry, it confused me. With iSCSI, we can do block level storage or file level storage. In the block, it is seen as a local drive. In the file level, it's just the specific files we're sharing. A perfect example of what this is your standard Windows share. From earlier, when you make a standard share, you take a folder and you set the permissions to it, then anybody can either go to the IP address of the server or the FQDN, and they see the files. That's file level. Whereas block, they would be seeing a mapped drive. That's the block level. So like I said, iSCSI runs on these logical unit numbers. It's basically the reference ID. So instead of using an IP address, we're using LUNs. You'll need the target server and provider in order to configure a target. You'll need to install the role in order for it to work. You'll need to create the virtual disk, and then you'll be able to attach it. And of course, there's a wizard that goes with this. I have been browsing eBay for storage arrays, and yes, a lot of boxes say iSCSI, and they have SPF Plus and power. Yep. Using fiber as the connection. Like I said, there is a wizard that you can follow to add iSCSI into Windows, and you'll need some information ahead of time to make that connection. built in, or it's built into Server 2012, so you'll be able to see it in 2019. You'll see the properties that you'll need to install in order to get this connected. And really, it's this information, the this location, this name, the size, the target, and the initiators, and any authentication that goes with it. The Internet Storage Name Service. Another way to share storage on a large network. So we're talking data center level. Still using IP as the base for the protocol, using fiber. This allows more connections, faster connections for data across many devices at once. So this is further up in making a backbone. You can do this in Windows. There is a feature that you can add and a wizard to follow. Here is your iSCSI. Here's an iSCSI name that's being added. The iSCSI has a funny little way of identifying themselves. There's also the data center bridging. When we have a server clusters and want them connected together, that's where DCB will help improve iSCSI to do things like quality of service, performance, and exchange between the two. Again, you can add this into Windows so that it becomes a bridge between clusters. So if we have multiple SANs and multiple servers clustered together using these multiple SANs, we can integrate them all together to essentially use the same storage, even though we're talking about different boxes interconnected. Definitely talking big data center level now, not so much the one little computer that is acting as a server for a small business. This is more of a bigger project. There's also the multipath I/O, handling fault tolerance, which is definitely necessary at this level where we're talking about multiple systems accessing storage. So you have a lot of files being read and written over the network very quickly. You want to have fault tolerance to prevent data store or to prevent data corruption, data loss, that kind of stuff. Here is the properties of that. Again, this is stuff that you're going to see in large infrastructure. But Windows is able to communicate with all this. You just have to add the role and feature. Data deduplication, or dedupe. Another way of copying data from one block to another block. It's a form of backup, really more of like a hot site, having multiple copies around just in case we have any storage issues. Great for file servers, because again, we're holding duplicated data in case data corruption. Great for backup servers to have those backup sets. Virtualization as well, because working with multiple VMs and many different uses, we want to be able to have backups in case something goes wrong. There is a tool that you can run to kind of give you it's your typical Windows wizard that'll tell you which way you could go, and that is this tool right here. You can add it. It's under the file and storage service role. There it is. Of course, you'll need some requirements. For example, it must be formatted NTFS. The physical or virtual machine running this should have at least one volume that doesn't have the OS. Anything larger than 64 terabytes is not supported. You should have at least 10% free space. Definitely should have it on fiber. And any encrypted files that are smaller than 32 kilobytes are not processed by this. Once installed, just like anything else, you have to enable it. And it's as simple as the right click on the volume and configure data deduplication. And you can choose, will this be a general file server, a VDI server, or a backup server? Here is the options, along with the schedule. So one of those things that you would probably want to do at night when there's no one around. The set up optimization, when to do it, what times to do it. Again, things to do probably at night when backups are done, or when no one's around, so that the system can work in peace and nobody will complain about system performance. Of course, you can do this, everything that just talked about, do it all within PowerShell. So here you go, showing a job underway and showing a dedupe. Of course, you can see the schedule and its status through PowerShell, just as you can with the GUI. Deduplication is one way. Another way is doing backups to restore full volumes or selective restores. That is always an option that you should have for your data. There is also the storage replica, another feature for file or block level replication between storage devices. Here's your primary way to handle fault tolerance and disaster recovery. With this, the servers could be remote. So you could have a whole nother site that has a copy of the data. This can be done server to server, cluster to cluster, or even stretch cluster, which is different geographic locations, like around the world. Of course, you need some minimum requirements to do this. Plenty of space, strong connections, part of the domain. What can and can't be copied out. Installed either through PowerShell or the server manager. Either one will get you to the same place. In PowerShell, you can see that the replication group that you're a part of. You can also do one-way replication, which is from one source to a destination and not the other way around. If it just so happens that your your primary system goes down, you'll need to remove the partnership and then bring the destination online. And that's the command to do it. And then lastly, you can either do it synchronous or asynchronous. Asynchronous would be great if we're talking about a slower or a high latency network, whereas synchronous would be for your typical strong, like an intercity communication, where you know that both sides have strong internet connection versus something that's a little more out there. Any questions before I hit stop recording? Looking. Okay.